you're free to. But I don't guarantee that it will work on any machine except this machine, because it's kind of a hacked together system that makes C++ work inside the Boost Python notebook, or inside the IPython notebook. It's, in principle, it works everywhere, but in practice, just here. So the plumbing test, that was the first test that I asked everybody to run. And if it works properly, it will just execute and print out some Python version information. So if you've got that working, good. The other thing with this, the other bit was the smoke test module, which is just the most sort of basic, simple Boost Python extension module you can imagine. All it does is print out the number 42. Of course, yes? Yes, BP module is part of, so if I go back to the IPython notebook setup bit here, this BP magic, that's where that is. So if in fact, I'll just take a meta note here. If anybody does spend some time to get this notebook working, this IPython notebook working on their system, let me know. Send me a patch or something, because I would love to have it work universally. I just don't have the time or resources to do it. So, open source. Yeah. It's part of the notebook that you can get. If you go to the Etherpad for this course, there's a link to the notebook. It's a Bitbucket or GitHub or Git something. Yeah, Gitbucket. Okay, so the smoke test is a simple module. If this works, if you can get those two things working, you're set to go. You have everything you need. Your system is configured, et cetera, to move forward with this. So I'm just going to kind of plow ahead. If we get to the point where it's all puzzled faces and glazed eyes, we'll stop and regroup again. I heard a sigh. Is that a sigh? Exasperation, or yeah? Are things still not working over there? Is it? It's working? Okay. Okay. So, hello world. We're obligated to do hello world by the rules of computer science. So let's expose a simple greet function in a module called hello world. So set the stage, very simple stage. I have a C++ function that prints out the words hello world, and I want to be able to call that C++ function from Python. I have to create a module that wraps around that function, and then I have to import it in Python and run it. That's what we're going to do right now. So how does that look? First thing, actually, even simpler. We're going to start with an empty module right now and work up to hello world. So it's easier if I stand here. I think the voice is recorded if I stand here. Otherwise, it's not. You see, okay, ignore, in all of these examples, ignore the %% BP module. That's IPython notebook magic stuff to make it work. What matters is everything beneath that. So the first thing you have to do is include boost python.hpp. That brings in all the headers for Boost Python and gives you access to all of the facilities of the library. You can include finer-grained headers if you want. If you know you're only working with extract or only with import or something like that, you can include finer-grained headers. And that can actually have a significant impact on your compile time for large systems. But for this workshop, I'm going to stick with including Python HPP. It's questionable practice, but it's simple. The next bit, maybe the most important bit, is this macro, Boost Python module, which is a macro that comes in from the headers you just included, and a name, empty module, we're calling it. And inside these curly brackets here, we're going to start adding a bunch of code that exposes functions and classes and things like that. But this is the high-level framework for all modules that you expose with Boost Python. A few little caveats that I may touch on later, but I'll just say them now. One is that this is the name of the module you're exposing. This name has to be the same name as the shared library you create. So if I compile this into a shared library, it has to be called empty_module.so. If you don't do that, when what Python does when it imports a shared library is it looks at the name of the shared library, the file name, the file system name of the library, foo.so. And then it looks inside that binary for a init_foo function. It manufactures the name at runtime and tries to look it up using DLSim or whatever your system call is. And if it can't find it, it says, you've given me an invalid library. So you have to make sure that the module name you pass here matches the name of the module you build on in your build system. Likewise, make sure, this has tripped me up when I was first starting, don't pass a string in here. Pass in a literal, not even a literal, just a symbol, just a name. If you pass in a string, I think compilation fails. So you learn pretty quickly not to do it, but still, it's just the little things that matter. But if I compile this, and we'll get to you actually doing stuff in a second here, I can then import empty module, and I can ask for the contents of that module. And what I get, nothing but the standard boilerplate, the doc string, the file name, the name, and the package, and so forth like that, all the dunders that are part of any module. So this is the most basic, simplest thing. If you haven't learned enough yet to be really effective, but there's not much more than this you need to know to have gotten a lot out of this workshop, I think. And we'll get to the rest very soon. Okay, I mentioned this, the boost Python module macro, don't pass a quoted string. You don't get anywhere if you do that. You'll learn quickly not to do it. And again, I already pounded this in. The library name, the library you build has to be named the same as the name you pass to the macro. So make sure that, well, in this case, so I've got a module called, I've told it it's going to be called Forskjellige navn, which is a different name in Norwegian, to mix it up a little bit. But then if I compile that to a module called different names, and then I import different names, it's going to tell me it can't import different names because it can't find a function called init different names. The function that exists is init Forskjellige navn. So this is, if you see this kind of error, that it can't find init something, probably what you've done is screwed up. You've got a name mismatch. So I'm kind of beating on this because you can spend a long time scratching your head trying to figure out what's going on. If you see this specific error, what you've done is likely just made a name mismatch. So really a key thing to know, a really important thing to keep in mind is the sort of execution flow of module imports. When you import a Python module, a pure Python module, it's fairly instinctive to recognize that the module is sort of executed at import time. Right? You import it, and all the top-level, module-level things are evaluated and executed at that point in time. That's not so common in C++. It's not a mindset that C++ developers have because they're so used to compilation time taking care of things. They're so used to not relying on static initialization because it's so indeterminate. It's actually a tremendous source of bugs. But when you import these modules, these C++ modules into Python, the stuff between the brackets is executed at import time. So you can set up code to do whatever you want. And in this case, I just demonstrate that very simply, by having the boost Python module body call a function called initialize. And all that initialize does is write out to a file and put some well-known text into there. You can run this on your own. Convince yourself that it works on your own time. But it does work, that you can put code that will be executed at import time into the body of your boost Python module. This is really, really handy because, as I mentioned, static initialization or initialization in C++ in general is a really hairy thing. It's sort of undefined, and you can have all sorts of bugs, and you have to really jump through hoops to make it work properly. But Python gives you a really graceful, really elegant way to initialize your modules, and you can use that in C++ here. This is really kind of beautiful. It's one of the nice parts about using Python, really, is the well-structured, well-ordered initialization. Yeah, there still are problems with C++ static initialization, but this gives you this is like a new superpower, kind of, that you don't have with just standard C++. So this is your first chance. In the student workshop material I sent out, there should be a file called helloworld.cpp. Your job is to make that into a Python module. The only things you should need to know to do that are here, to include Python HPP and to use this macro. The make file should be set up to build that for you once you have everything in place. So let's take a go at that. Does everybody have that file, helloworld.cpp? It's in the workshop directory. Okay, take a few minutes and try it out, and we'll regroup in a couple seconds. No, this is kind of half-assed, not real code. This is to remind you, yeah. Well, this has to follow C++ syntax, but no, this is not legitimate Python or C++. This is to remind you that the module name goes in there. It's non-syntactically correct placekeeper. Hmm? Yeah. You can make enough clones. The make file is going to do this. You can say make wants to go to this file. So go ahead and modify this file. Yeah, just to reiterate, the goal is to modify this file to be a Boost Python module you can then import into Python. So let me go back to the hints so you don't forget. This is all you need to do that. And if you have questions, just let me know. I need to get everybody on the same page. It doesn't need Python.h, it needs Boost Python.h. virtual machine image, use Python 3 or IPython 3 as your Python executable, and things should just work. So you got to.
No, I got a question. So what makes Boost produce a Python 3 module you're saying it does produce Python 3 module that works, and trying to work Python 2 doesn't work.
Yeah.
What is,
So if you look at make.com, this is cat.com. So what I'm doing is calling this function, this program, Python 3 config, and it's spitting out C flags and LD flags I'm supposed to be using. I just dumped this in my C and my G++ command. And so basically, I'm asking Python 3 to tell me which libraries and headers to link to, and that's how it's all data stuff done. So if you change 3 to nothing, I'll automate to. It's not too bad.
that's great. That's good.
What is extension suffix supposed to be spitting out for Python 2?
That's a good question. If it doesn't exist, just probably use SO. This is on Linux, or might be DL, Dyn DL, or something like that. Let me see. It's .so.dsim, whoever I was just talking to. So who's been able to make it work? Just a show of hands. Okay, so pretty good number of people. Okay, we'll give it a few more minutes. Who else is still working on it? Who hasn't given up yet, but is still working on it? Okay, that's enough. That yeah. Let me check with him, and then I'll come check with you. So is the pieces all fitting together now?
Everything's working.
Okay.
It's just, for reference, the expression machine cannot control Python 3 notebook.
Oh, okay.
Has to train the LPS.
Okay, that's weird. Okay, so did it go out to the internet and decide that it needed to update?
First before I understood the real.
Oh, geez, okay,
I did the Python notebook, that worked, but then I just tried to
okay,
Python 3 notebook.
yeah,
And it's like, it has to do with the
okay. Okay, sorry about that. Okay. Okay, I'm gonna move on to the next little bit here, but it's not going to be so far ahead that those of you who are so it's really just a small extension to what we've seen so far. So what we've done now, if you've done this, you've created a module that doesn't expose anything. It's just an importable module, but that's a huge step. That means all of the infrastructure is in place, and the rest of this is just adding code to what we already have, which should be much quicker. So the first thing, and honestly, one of the most important things, maybe the most important thing you can do with Boost Python is expose C++ functions to Python. So you have some C++ function, you want to call it from Python because it's really fast, and you'd like to be able to use it from Python. The secret to doing that is the def function. I think it's a function. It might be a type. I honestly don't know. And it's really, really simple. So you see here we've got some C++ function, CPP function. It takes a string reference and returns an int and does something in the middle. Doesn't really matter what. To expose that to Python, I use my Boost Python module, as we've been doing, and I say Boost Python def. And I give it the name that I want to expose in Python. So this can be any name you want, as long as it's a valid Python identifier. It doesn't have to match the C++ name, as you can see here. So that's the first argument, is the Python name, the attribute name. And the second argument is the name of the C++ function. I think you can also use address of if you want, but for simple functions, it doesn't seem to matter what you pass here, just the name of the C++ function. So this is a lot. If you leave this workshop knowing how to do this, you've gained some pretty significant new powers, because this is really, really easy. This is part of what attracted me to Boost Python versus the other options, things like, well, there's a whole universe of things now, things like Python and so forth. But when I first learned Boost Python was how simple this was, how close to Python this was. So you can see all I have to say is def, some Python name, some C++ name, and imagine the machinery that's going on at compile time here, because we don't tell Boost Python anything about the argument types, the argument count, the arity for this function, what it returns, or anything like that. It's all figured out using incredibly complicated template metaprogramming. So if you ever want to be smart in C++, learn how this works, and you will be smart in by definition, smart in C++. I mean, the guys who wrote this were really, really sharp. David Abrahams is the main author, as I recall. This is as close to magic as I've seen in any library in my life, to be honest. What they do is incredibly, incredibly cool. You pay the price in compile time, but that's a small price to pay for looking good. So that's how you expose. Oh, are you raising your hand for a question? Yeah. Okay. We will get to that. It will work. It will compile just fine. I believe that's the case. But at runtime, there's a whole runtime registry of type converters. And if you don't register type converters at runtime, when you try to cross the language boundary with those types, it will just fail. I think that is entirely true, but let me think. Talk with me afterwards if there's specific questions. Was there another hand? Oh, okay. Okay. Yeah. Mm. Yeah, I've done small experiments on my own to satisfy myself that this was not substantially slower, in some cases faster than the options. With that said, I know very smart people who say that Boost Python is slower than Shiboken and Scython and some of these other options. I don't know what the variables are that control the performance differences. It could be that we just had very different use cases. I don't know. But I've never found this slow enough to like pique my interest. It just kind of works. There should be a benchmark, I suppose. I mean, who was it? Not the PyQt guys, but the PySide guys started with Boost Python and decided it wasn't fast enough and moved on to some other technology. I know that. So there are people who have said this isn't fast enough for their needs. In my experience, the driver behind which technology you choose for this kind of work is much more driven by other needs than performance. Do I have a large existing C++ code base and I'm already using Boost? If that's the situation, you probably can use Boost Python pretty easily and seamlessly because your whole infrastructure already uses it. If not, Scython might be a better solution. There's architectural decisions basically drive. And yeah. Mm-hmm. Well, there is a code generator that comes with Boost Python. I forget its code name, but I've literally never used it. It's interesting, but and this is probably largely driven by the kind of work I've done, but I just handwrite all of this code. Yeah. Right. So, okay, so back to the point of this slide, Boost Python def. This is how you expose functions from C++ into Python. Very simple, very easy to remember because, of course, def is the function keyword in Python itself, which is there's the great parity here between the languages. So the next obvious step is I want you to expose the greet function. I know some of you have already done that, but go ahead and expose the greet function in the module you just created. All you need to do is use def in principle, unless I've left out key important steps. So give that a shot, and let's see if we can get everybody on the same page again. I flew in, I got in at 11 o'clock p.m. the day before yesterday, but it generally takes me, tomorrow I'll be fine, but this is often the worst thing, is the midweek for the afternoon. But they give me plenty of fuel here, so. Yes, you do, because that's a good point. So his question was about the binaries we generate between Python 3 and Python 2. The shared modules are very different and will not interoperate. From Python 3 onward, however, the ABI for Python has been frozen, and in principle, Python 3.3, 3.4, 3.5 ad infinitum should work. I haven't tested that, but that was the goal of the ABI stabilization, as I understand it. Yes, 99.999% of the time. I can think of one instance a few years ago where I had to change something. And, well, okay, it'd actually be worse than that. It depends on how heavily you use the Python C API, because there are variances between Python 2 and Python 3 that are pretty significant, for instance, in string handling and stuff like that. It's going to depend on your situation, but it's all manageable in my experience. Yeah. I believe so. I think recent versions of Boost should be C++ version agnostic. They hide it from the covers, so they should work on both.
Basically, I understand that Boost Python is very old.
Oh, yeah. Yeah, Boost Python is relatively old, at least 10-ish years old. But it hasn't gone through a whole lot of change. It was like develop. They made a version 2, and since then it's kind of been very stable. So have we had success in exposing the function? Anybody struggling? Everybody happy? Okay. Okay, if you leave now, you have learned the vast majority of what's really going to help you in Boost Python. Being able to take a C++ function, expose it into Python, that is most of what people end up in practice using Boost Python for. I don't want you to leave, though. I want you to stay and learn more, because we'll learn about classes and enums and all this kind of stuff. But if you decide to go to sleep now, it's okay. You've gotten your money's worth out of this workshop. There's plenty of free caffeine out there, so please don't go to sleep. But this is good. So I just want to make absolutely sure everybody understands how this works. Everybody kind of gets it at this point. The railroad is connected. Okay, I'll take that as a yes, and we'll move on, and we'll take a break here just in a short bit. So the next thing I want to do is modify the greet function to take a parameter, a name parameter. You can take a constant string reference, whatever you want, really, and have that print out. So update your greet to take a string parameter, and then rebuild your module and see that it just magically works. Yeah. The short answer is yes. I believe that by default, the Pi objects that Boost Python is working with have a shared pointer underneath to the thing that they're referencing, the C++ thing they're referencing. So you may end up with 2 levels of reference counting, but it should be invisible. That's controllable, but it's something that I've only had to do maybe once in my life to have it use a different kind of reference or something like that. Yeah?
So I just want to
Two eyes. Two sets of eyes, I mean, yeah. Well, that's the rubber duck, right? Yeah. As soon as I look at it, you see it automatically. So I'll send you a bill. Okay, everybody happy with that? So the big takeaway from this slide is really that you added a parameter to your function, and you didn't change anything in your Boost Python function definition. It just worked. It was just magic. And this kind of goes back to this deep voodoo that's going on here. It's really impressive C++. It definitely works. With, I'm sure if you use just a non-reference, non-const string, that would work. Const car pointer, I'm not sure what it would do. There's certain things it will balk on and say it doesn't know what to do, and you have to give it further instruction. Yeah. Is there another question? Okay. So we'll move on from that. So now instead of this, we're just going to iterate on this greet function a bit. Now add a return value. So instead of having greet print out something, have it just return a string, and then you can actually use the return value from Python and print it out. So this is just more instruction, more instruction. So that should have been pretty easy. I hope that this is all very straightforward now. You see the iteration is very fast. Nobody having any trouble? Nothing? Okay. Still making the changes. Oh, okay. Come on. By the way, is anybody using the Visual Studio solution that I created? Nobody? Are you are? Oh, okay. very, I don't use Visual Studio, so I kind of had to fake my way through creating the solution, but I did create it. If you have ideas for improvements, let me know. I'd be happy to try to integrate them. I do know CMake, yeah.
Basically, you just
Oh, it just produces everything?
in like 5 lines, and then you can generate for Visual Studio or
Okay,
make file.
that's really good to know. Yeah.
It's copy and paste it.
Yeah. Oh, well, oh, I see how this is. Okay, okay.
So, it doesn't create, no, I mean, it works.
Oh, no, no, so it's printing it, and then.
Oh, okay, that is,
That's, no, it's only in print version. I'm not sure what it is. Oh, wait, can you show me your C++ file? Oh, no, so you need, well, okay, for the slide we're on now, this, you should be returning a string from this function instead of printing it out. So go ahead and change it to something where the greet function returns. Okay. Yeah, I'm fairly certain the string is copied under the covers there. Yeah, into some. If we get to the type conversion system, you'll see some of the deeper details of what's going on under the hood. There's basically an allocation of the right size and an in-place initialization, in-place construction of objects going on. Yeah. Oh, okay. IPython, you're running with Python 2 here. Are you sure you compiled that with Python 2? Slow down. Okay. This is OSX. Yeah, you may have just stepped into a landmine of landfill minefield of trying to make versions of this together. This is basically a binary category, and if your Boost Python isn't built against your Anaconda installation, the chances of them working together are very, very small. Yeah. But you have enough research. Can you get it working otherwise? You think, or?
I'll follow along and I can figure that part out.
Okay. Okay, so I think that's the end of the kind of the first section here. Yeah, so let's take a, 10-minute break? Whatever people need, bio break. Okay, meet back here in 10 minutes.